Picture this. You're a company with a powerful new AI model, and this model is ready to learn from some highly valuable, sensitive data that took months to gather. This data is the lifeblood of your model. It's what's going to give your AI the edge, the secret insights that can make it a game changer. But there's a problem. You've got to decide where to store and process this precious data. You've got two main options: send it off to the cloud or keep it close on local hardware. Let's say you decide to go with the cloud because it's fast, flexible, and can scale up as your needs grow. It's convenient because you don't have to buy any expensive equipment or worry about maintaining hardware yourself. With just a few clicks, you've got massive computing power on demand. But here's the thing. While the cloud is incredibly powerful, it's not a completely safe vault. Choosing to send data off-site introduces risks at almost every step of the way. To understand these risks, let's follow your data on its journey from your company to the cloud and look at each stage of its journey with a fine-tooth comb. Now imagine pressing send on that data. Instantly, your data is on the move, broken into smaller pieces. Think of them as little packets, each one taking its own path across a network to get to the cloud servers. This part of the journey is like mailing a valuable package across the country. You might start with a carefully packed box, but once it's out of your hands, it travels through all sorts of stops and checkpoints before it gets to its final destination. Along the way, there are all kinds of vulnerabilities. At each stop, there's a chance for something to go wrong. For example, imagine someone along the route intercepts your data. Hackers can use a technique called packet sniffing, which is basically a way of spying on data as it travels. Just as someone could open your mail to read what's inside, hackers can tap into these data packets and see the information if it isn't securely locked up. Encryption helps protect data by locking each packet like a sealed box, making it harder for anyone to see what's inside. But encryption isn't perfect. Skilled hackers have tricks up their sleeves. One classic trick they use is called a man-in-the-middle attack. Picture a con artist who sneaks in between you and the cloud, intercepting the data as it travels. And this person could open your package, peek inside, and even change the contents before sealing it back up and sending it on its way. The worst part? You'd never know it happened. With AI data, this kind of tampering can be disastrous. Imagine a hacker intercepts sensitive training data, changes a few details, and sends it along. The AI model then trains on this altered data, which could lead to skewed predictions or even harmful decisions. Your AI might start seeing patterns that aren't real, making flawed assumptions, or giving out bad advice, all because someone slipped in fake information along the way. But let's say our data makes it past that first hurdle and arrives safely at the cloud server. Here's the thing, though. In the cloud, data doesn't just sit on one server. It often moves around within the cloud provider's massive infrastructure. It's transferred between different servers and sometimes even between data centers for things like load balancing, redundancy, and backup. This is like having your package move from room to room inside a giant warehouse. Each time it moves, there's a new door it has to go through, and every door is a potential vulnerability. Remember, the cloud is a shared environment. It's like renting a storage unit in a warehouse where hundreds of other people also store their stuff. Now, the cloud provider does a lot to keep everything separate, using virtual walls to keep your data from mingling with someone else's. But if someone finds a way to break through one of those walls, they could potentially access other data zones in the system. Think of it like having someone pick the lock on one storage unit and then figure out how to get into all the others. In a shared cloud environment, a single weak point could expose multiple areas, putting everyone's data at risk. Then we have the issue of APIs, which, in simple terms, are the doors that let different parts of the cloud communicate with each other. APIs allow applications to talk to each other, but they're also a common target for hackers. Imagine leaving a back door open in your house, even if everything else is locked up tight. That one open door gives someone access to the whole place. Poorly secured APIs can provide an entry point for attackers to slip in and start exploring the data, possibly tampering with it, stealing it, or even using it to access other parts of the system. Let's pause for a moment to consider something fundamental. Human error. When it comes to cloud security, simple mistakes are some of the most dangerous vulnerabilities. Setting up a cloud environment is complex. It involves configuring tons of settings, permissions, and security measures, and just one misstep can leave your data wide open. One of the most common mistakes is leaving a storage bucket exposed. Picture this like a file cabinet that's accidentally left unlocked and open in a public space. If someone finds it, they have access to everything inside. In the cloud, a misconfigured storage bucket can be left open to the internet, allowing anyone who stumbles upon it to see sensitive data. Another common issue comes down to access controls. If permissions aren't set correctly, you could end up allowing access to people who shouldn't have it. This is like failing to change the locks on a door after an employee leaves the company. Without proper access controls, unauthorized users could access sensitive data, and firewalls, which act like security guards, also have to be carefully configured. If a firewall is set to allow traffic from any IP address, it's like giving out a universal key that lets anyone walk right in. As if these risks weren't enough, let's talk about the legal side of cloud storage. Different countries have different rules about where data can be stored, especially when it comes to personal information. Some countries require that data about their citizens must stay within national borders. For example, if you're handling data from European customers, you might be required to store that data in Europe. But if your cloud provider stores it on a server in the United States, you could be breaking international law without even knowing it. This is called data residency, and it's not something you can ignore. Moving data across borders can expose it to additional legal risks and even government access. In some countries, the government can demand access to any data stored within their borders. This means that if you're using a foreign data center, there's a chance the local government could get a look at your data, even if it's supposed to be private. Now let's look at the alternative, local hardware. This is the option of keeping data on servers you control, right on your own property. It's like storing your valuables in a safe you own with locks and guards you can trust because they're entirely under your control. Local hardware gives you the ability to implement your own security measures, making it much harder for outsiders to gain access. Since the data never has to leave your facility, there's no need to send it over networks where it could be intercepted. You're also avoiding the shared infrastructure of the cloud, so there's no risk of other companies' vulnerabilities spilling over into your environment. Local hardware isn't without its own challenges, though. Setting up and maintaining your own servers is costly, requiring specialized equipment, space, and skilled staff to manage it all. It's not just about buying the hardware, you also need to ensure it stays secure, updated, and compliant with industry standards. Plus, while local hardware gives you greater control, it doesn't eliminate all risks. If the hardware isn't properly maintained or security updates are missed, you could still face vulnerabilities. It's like owning a car. You have full control, but if you skip routine maintenance, you're inviting problems down the road. So what does this all mean in the end? Choosing between cloud and local processing is a balancing act. The cloud offers unmatched flexibility, but it also means opening up more doors where hackers might slip in. Local hardware gives you control and potentially greater security, but it requires significant investment and upkeep. For some, the cloud's convenience outweighs the risks, while for others, the security of local hardware is worth the extra effort. But whichever option you choose, it's essential to understand the potential vulnerabilities and take every possible step to protect that precious data. Because, in the world of AI, data isn't just an asset, it's the foundation of everything.